Hello and good morning to everyone. I'm Shantanu, an educator and astronomy enthusiast from Space India. It is my honor to welcome everyone joining us in our today's panel discussion on the occasion of Asteroid Day. The major objective of Asteroid Day is to spread awareness and educate the society on asteroids, also called planetoids, are remains of failed planets which could not form, are mostly located in the asteroid belt and between Jupiter and Mars. These rocks, all put together, would weigh less than a moon. But when they approach Earth at alarming speeds, any collision could potentially be disastrous. There have been incidents in the past history of our planet where these asteroids collisions have played a course changing role. In the initial years of formation, collisions and important organic compounds to Earth, thus helping in the development of life. But was responsible for the extinction of a large number of species, including the dinosaurs. The Tunguska event of 30th June 1908 was one of the most harmful asteroid events in the recent history. Asteroid Day marks the anniversary of the Tunguska event to create awareness about asteroids. Asteroids are our friends and enemies. It has become necessary to keep an eye on these sneaky objects that are seemingly just waiting for an occasion to collide with us. Efforts have been made by the global scientific community to discover, track, and maintain records of asteroids, especially the ones near us. And chances of any collisions, and to maintain techniques are being investigated that might help mitigate any future collision or minimizing its effect. In the most latest scenario, the curious minds have also sparked the idea to mine these rocks for materials needed on Earth. Asteroids are more important to our lives than most of us actually might realize. Waking up, an average person might hardly think of an asteroid, especially as a threat to them. Their lives are easily lived without a thought of these rocks. But these space rocks are more interesting than how dull they might appear. They hold secrets and knowledge that might help us advance and perhaps survive one day. Through Asteroid Day, science communicators all around the world contribute towards making society aware of all the above aspects of asteroids, their dangers, and as well as their benefits. Today, I have been joined by some of the very well known experts from the field, people of expertise in these space rocks, who have graciously accepted an invitation to educate us on various aspects of asteroids. It is my pleasure introducing Mr. Arvind Paranjpai, Director of Nehru Planetarium, Mumbai, Mr. Sachin Bhamba, National Coordinator of Asteroid Day and CMD Space India, and Mr. Rintu Nag, Senior Scientist, Vigyan Prasad. These three eminent guests would be the speakers for our first panel for today. Our guests will be speaking on specific topics ranging from the dangers of asteroids to asteroid mining. So, with no further ado, I would like to introduce our first speaker, Mr. Sachin Bhamba. He is the national coordinator of Asteroid Day from India and also the chairman and the managing partner of Space Group. Mr. Sachin Bhamba is an Indian born entrepreneur and philanthropist who has been a pioneer in introducing and revolutionizing the concept of spreading astronomy and space science in every sector, from education to tourism. His effort has been instrumental in establishing India's largest private astronomy and space science company. He is also the largest non government employer in the field of these sciences. His passion and vision to popularize science and spread scientific temperament among the masses, especially young minds, has led to the creation of the Space Group of companies. His vision has been instrumental in the growth of space, from the initiation of new programs in the education sector to development of astrotourism as a concept. Mr. Sachin Bhamba is a disciple of physics and hands-on pedagogy, an educationist with more than 20 years of experience. He is an avid amateur astronomer, a wildlife enthusiast. He is the president of India chapter of Space Tourism Society, USA. National Coordinator of World Space Week from India, National Coordinator of International Astronomical Collaboration. He is also the founder of Astronomica and ECA, or Eclipse Chasers Athenaeum. He is also the scientific advisor from Cheruvattur, Kerala. We would like Sir to address the audience with his kind words. Thank you, sir.
Yeah, thank you, Shantanu. And it's nice to see such a wonderful panel this morning discussing asteroids. And you very rightly put forward that asteroids are our friends as well as enemies. I think astronomers who are sitting with me understand what I am trying to say, and that probably would be the what we are going to present to people who are listening to this. That why it is so important to celebrate this asteroid day, and why it is so important for us to keep track of these asteroids. And both the panelists, including me, I only have discovered one, but I think Arinde has already discovered many asteroids. Studies and discoveries. So let's begin with why do we celebrate this asteroid? As you rightly put that there was an event in Tunguska, which is in Siberia, on 30th June 1908, and we celebrate Asteroid Day as an anniversary to that particular event, so that uh, the harm that asteroids can bring to our society, our families, our community, and the catastrophe that it can bring to Earth can be taken care of. We all know that, or and I would like to tell that if we are able to track an asteroid, uh, we are safe. For example, if an asteroid is heading towards Earth and we are able to track it not before 6 months of its course to Earth, it would be very difficult for the present science and technology to manage or divert that asteroid from bringing the catastrophe on Earth. So I think this is one of the most important contribution that any astronomer or students can give to the community, that they track all these asteroids. And on 30th of June, few visionaries that co-founded the Asteroid Day. I would like to take the names of Stephen Hawking, Bryn May, then astronaut Michael Collins, Kip Thorne, Martin Rees, and particularly Bill Ney, Louis Thomas Jones, Rusty Schwackart, who started this Asteroid Day. And the purpose was that we make aware people about what kind of uh, threat these asteroids pose to us. And particularly on this Asteroid Day, we did a declaration which is called 100x declaration, which basically means that there is more than 1 million of potential hazardous asteroids or rocks which can harm us. And right now we are not able to track more than 10,000 of it. So 100x simply means that we will collaboratively create an environment where 100 times more tracking can be done of these asteroids, so that they do not bring any harm to us. And being the national coordinator of India, we have been trying to involve level to work with us in keeping track of these asteroids. And one particular project that we do is All India Asteroid Search Campaign. And I would like to tell everyone that Indian students have performed wonderfully, and more than 2,400 asteroids have been tracked or identified by them, out of which 108 were new discoveries of these asteroids. And there's a huge number of students who are continuously helping astronomers to study this data. And then once they track something new, it is sent back to the university, which is helping us. Dr. Patrick Simmons is heading this project, and we send this data back to Hardin Simmons University. The data is given to us through Hawaii's Pan-STAR Observatory, and data is analyzed by students, and we keep track of these asteroids. So if students are able to find an asteroid which has already been discovered, it is called a near Earth observation. And if it's a new asteroid, but the track has not been identified, this means that we have identified a new object, but we do not know what is the path of that object in space. Then it is called a provisional discovery. And finally, once the track is established, it is called a preliminary discovery. So a lot of students are participating in this project.
Yes, sir.
Okay. So, as I said, these are the people who initiated this: Dr. Bryn May, Dr. Gregory Richards, Dr. Rusty Schwartz, and Dr. Ed Lu, who is an astronaut, and the 100x declaration that we talked about. So, Space India over the years have been doing a lot of activities. We are associated with the Asteroid Day for far more than 5 years now. and we take our activities to various students all across India. So you can see here some school students celebrating Asteroid Day. It is a government school in Haryana, where the students were interested in creating their own asteroids, and you can see, the event was a success as many students come forward and observe the asteroids that we let them make hands on. And again, in Chennai, you can see, the SETS Club of Raj Lakshmi Engineering College in Chennai. There are students who are actually learning about asteroids, and you can see the felicitation done there. Uh, Again, we hold an asteroid day quiz competition, which is done every year, and this year also, the asteroid day quiz competition will be held. So it goes on. The activities go on. They start from today, and they will go on. Then there are various competitions held at various schools. You can see Sri Venkateshwara International School, Dwarka. The students are participating in making an asteroid using clay models. So basic idea is to make them understand what asteroids are made up of, and keep them involved into this particular activity. Then, interesting and imaginative activities done by our educators at KR Mangalam School, colorful asteroids. Then students learn about the first 10 discovered asteroids, and few more activities for all of you to see on your screen. Multimedia presentations, and you can see very small kids are also interested in creating these space rocks, because ultimately it's a fascinating concept to understand that we are also living on a rock, and there are a lot of rocks that cross our way. And one such rock at some point of time was a very dreadful rock which actually abolished the uh, uh, hit the earth, and we had a very big impact. The dinosaurs were completely ripped off the earth, and similar things can happen in few coverage on the media. Now, why involving students? I have already told about a lot of things, that why do we involve students to these kind of activities. Because asteroids are really tricky. If both of the astronomers who are sitting will actually agree with me that while we were all looking at one of the asteroids uh, on 5th, I think 5th of 6th of June, to 2002, NN2, which was being looked for. Because when we talk about asteroids, we are only worried about the asteroids which are very near to Earth. So we measure that the asteroids which are near to Earth can be measured by the, taking a unit of distance between Earth and Moon as one unit. And on 6th of June, everybody was looking forward to an asteroid which was going to pass from a very safe distance, which was 13 times the closest approach, which is the lunar distance. So if we take one unit of the distance between Earth and Moon as one unit, so it was going to pass from 13 times away from this unit. But suddenly on 5th of June, another asteroid which passed between the Earth and Moon, which was not discovered by any astronomer, and it was a sudden asteroid that came so near to us. It was 0.80% of the distance of Earth and Moon, and nobody knew about this asteroid. And had it been on the collision course to Earth, it would have been a catastrophe. So the asteroids do these kind of tricks, and it is very important for us to take care that these asteroids are tracked. And for this very reason, in fact, tomorrow also there is an asteroid which is crossing very near to this distance. It will be 1.84 times the distance between the Earth and Moon. So these are close asteroids which cross our Earth. And I also want to tell the students who are listening us that we are just safe sitting on Earth because we have an atmosphere surrounding us. And if an asteroid or a meteor, which is again a rock, enters the Earth, we see them as shooting stars, which burn in our atmosphere because of the presence of atmosphere and the friction that it offers to these kind of rocks, which are entering the Earth atmosphere. But if we are on a collision track, or there is an asteroid or a big rock which is in a collision track towards Earth, and it is bigger than a particular mass, let's say more than 800 kgs, or more than the size of a Maruti 800 car, then probably there is a chance that it will come and impact us. and once asteroid hits an Earth, the kind of energy it produces is much more than the nuclear bombs that we have seen giving devastating effects. So it's a important science, and today, as a coordinator of Asteroid Day in India, I would only request more and more university and school students to join this campaign of tracking asteroids. It is a wonderful research. You can actually serve your community. You can actually save the Earth from this catastrophe, and also it is a lot helpful in your career. The certificates that you get help you in taking and pursuing science further in your life. With this message that we are looking forward to more and more people joining us into tracking these asteroids with us, and helping us to save the Earth. In this era of Corona, when we are all sitting at home, this is a wonderful activity to take up, and there is a possibility for all of you to join us. There is a continuous research going on. As I said, Patrick Miller, who heads this International Asteroid Search Collaboration from Harding-Simmons University, offers a wonderful opportunity for all students all across the world to participate in this asteroid search. And next time when you see a shooting star in the sky, and if you make a wish, the best wish could be that it burns in the atmosphere and does not come and hit us. So with these words and a small report about what are we doing and how there is a possibility for students to join us into this asteroid search, I would like to pass on the dais to my seniors. Both of them are wonderful, passionate astronomers, and I have learned a lot from Arvind. We have been friends, and have been meeting at a lot of places. I have not yet visited the planetarium at Mumbai, but I hope to visit planetarium Mumbai soon. And I would also want Arvind, to tell his passion and his asteroid search. And also, I am looking forward to listening to Dr. R. Nath. Thank you, Shantanu, and thank you, everyone.
Thank you so much, sir, for this wonderful introduction to the event. Sir, we have one question for you from one of our viewers. And sir, the question is that you were just telling about an asteroid that came very close to Earth. And in the same time, there was another asteroid that was already closer, but was not discovered before. So the viewer wants to know, sir, how is it possible that the asteroid could be so close to us and no one had seen it just before it passes by? So please answer the question.
See, it's a asteroids are wanderers. They are just moving around, and the asteroids are created by a lot of things that happen in space. Space is also kind of a living system. It creates debris. So asteroids are created by many ways, and we have not yet tracked all the asteroids. That is the purpose of signing that 100x declaration, that we should be able to track all the asteroids. Now it is also tricky. Once we have tracked an asteroid and we think that it is in an orbit and it has taken its path, then anything can disturb its path. It can have a small impact with another asteroid and start moving towards Jupiter or start moving towards another planet and change its track. Now we identify anything by its position. So if it changes its position, it becomes a new asteroid. So it might have been an original asteroid which was tracked and around an orbit which he identified, but since it changed its orbit, it was lost. We thought it was lost, but obviously we know that gravity is again a wonderful thing, which brings things go away from a body and then drop back, because as soon as there is a change in the energy of that particular body, it comes back. So there is a huge possibility that the asteroids that we have already tracked and numbered, they can become rogue asteroids and can be seen in a different orbit. So they will be identified again. Now, what happened right now, what I was explaining was that, we already had a tracked asteroid, which was 13 times away, 13 times away from if we take one unit as sun and earth and moon as one unit. So it was 13 times away. And we were tracking that, we were interested to see that, this asteroid is coming. And suddenly one more asteroid, which is a rogue asteroid, which we had not tracked, came in between the Earth and Sun. So it was a very near approach. Now your question was, how can it happen? It can easily happen because we are tracking asteroids and they change their track and they become new asteroids for us. And second thing, the most important thing is, the kind of technology that we have and the number of asteroids that are there, and the huge distance that is universe, there is a possibility of always finding a new asteroid. Now, interesting thing is, we could see it, and it is now tracked on 7th of June, and it was not a very big asteroid, but there is always a possibility that, asteroid becomes a rogue, becomes a new asteroid, or a new asteroid enters a trajectory which is troubling to us, and we always all on the move doing it. As I said, there is a huge possibility that we might not be able to see a asteroid which is coming on the collision track to Earth, and we just hope that we discover it at least 6 months before its time of or the day of impact, so that we can do something to save ourselves from it. And that is the purpose of it. Yeah.
Thank you so much, sir. Now, our second guest is a renowned personality in the field of astronomy and space science, Mr. Arvind Paranjpai, Director, Planetarium Nehru Center, Mumbai. Mr. Paranjpai completed his master's from the Pune University. I would like to quote him here. For the most part of my life, I have been interested in astronomy, which accounts for my hobby, passion, as well as my career. I have been interested in various hobbies from stamp collecting, ship and boat modeling, photography, etc. I had been an amateur astronomer since my college days. Mr. Paranjpai's professional career started with as an assistant in the photographic laboratory of Indian Institute of Astrophysics, Bangalore, India, in December 1990.
Shantanu, I can't hear you.
Period, he took site survey observations for high altitude infrared observatory. Upon return from Leh,
Now I can.
I'll just.
It's
I'm
fine.
audible now, sir.
It's fine. Yes.
Mr. Yes, sir.
Bandwidth.
Okay. Upon return from Leh, he was involved in the search for the minor bodies in the solar system. In 1988, his team became the first Indians to discover a new asteroid that was named 4130 Ramanujan. They were awarded Astronomical Society of asteroid. Asteroid 717446 Mopaku was named after three members of the team: Venkatachala Murthy, Arvind Paranjpe, and Kamati Chiappan Kupuswamy. The asteroid was discovered on January 23rd, 1990. For a short period of time, he also took some spectroscopic observations using 1 and 2.3-meter telescopes at Kavalur. Later, he joined the Inter-University Center for Astronomy and Astrophysics, IUCA, in April 1991. Initially, he worked on development of low-cost instrument for astronomical observations and carried out on-site survey observations. He had been involved in science popularization activity of IUCA since the day it started. As an amateur astronomer, he had observed and photographed major total solar eclipses, annular solar eclipses, and transits. He has been contributing columns or short stories to various newspapers and periodicals on skywatching and astronomy. Q&A such as Indian Express, The Times of India, Tarun Bharat, Sakal Saptahik, etc. From time to time, he has been on radio and television. He was the expert in a science quiz show called Chamatkar on Doordarshan since 1998 to 1999. He has been hosting live Sky Show on All India Radio, Pune and Mumbai. As for publications and academic journals, he has about 10 papers on site surveys, spectroscopy, occultations, and search for minor bodies in the solar system. Sir is also a member of Astronomical Societies of India's Public Outreach and Education Committee. Sir's journey has been an exciting since the start. Now we would like Sir to tell us more about the history of the asteroid discoveries in India. Please, sir.
Thank you so much, Shantanu, and thank you so much, Sachin, for inviting me for this wonderful morning. And it's been a long journey with the asteroids, and many others would be talking about the modern technology and impact of asteroids and etc. I thought I will share certain historical aspect of discovery of asteroids. The reason is that many times we tend to forget what history has given us, and which is equally very important. So, discovery of asteroid, I think it should go to. I mean, the basis of goes to Copernicus. I think he was 1473 and 1543. So just before he published a full book in which he talked about how the planets are going around the sun. Now, why this is important is because once you consider that the planets are going around the sun, then it becomes easier for one to identify, or easier for one to talk about distances of planet from the sun in terms of Earth-Sun distance, which we now call it astronomical unit. Earth-Sun distance is now called an astronomical unit. And how do you do that? You keep observing the planet, inner planet, that is Venus or Mercury, and keep taking their measurements, angle between sun and that planet. Now, this orbit of Venus is inside the orbit of the Earth, and therefore the angle increases to a certain extent, and then it starts decreasing. So when the angle is the maximum, that is the time that now please remember that I am talking about circular orbits of planet. The elliptical orbits of planet came later on, but circular orbits of planet. So when the angle is maximum, the line joining that planet and Earth and the sun is a right angle triangle. And once you have right angle triangle, then you have this beautiful trigonometric equation, which is sine theta equal to Venus sun distance divided by Earth sun distance. So with that, you can get the distances to the planets. Very similar exercise was carried out for the outer planet, but which is a little bit more evolved. So I will not get into that. But point I would like to make is that once you have understood, once you have accepted that the planets are going around the sun, then things becomes much more easier, straightforward to get the distances of planets. Now, by then, you don't have to get new measurements because people had done large amount of measurements. And so when you did these measurements and angles, etc., you found that Mercury was about 0.4 distance, okay? Taking Earth sun distance equal to 1, then Mercury is 0.4, Venus is 0.7, Mars is, Earth is, of course, 1, then Mars is 1.6, Jupiter is 5.2, and Saturn is at 10. Now, a very interesting thing takes place, that there is a German astronomer, mathematician, TTS, John Daniel TTS. He comes out with a beautiful mathematical equation. And what he says is, to how to remember the distances of planet from the sun, is that write these two numbers, 0 and 3. The next number is double of 3 is 6. Then double of 6 is 12. 24, 48, 96, and so on. So then what you do is add 4 to this number and divide by 10. So now if you do this calculation, then what you have is again 0.4, 0.7, 1.0, etc., which actually fits into the very exactly into the planetary distances. But we also find that at between Mars and Jupiter, that is at 2.8 astronomical units, there is no other object. And people thought that it is by chance and no one bothered really. So it was not considered too much and they just lived at that. But then on 13th of March 1781, English astronomer William Herschel, he discovered a new object which was beyond Saturn. And that changed everything. Because when they calculated that distance, they found that this distance exactly fits into this Titus law. In fact, the thing is that the TTS, when he proposed this, he just proposed it mathematically, but his countryman, another board, he actually popularized the model, this particular equation. So we call it TTS board rule. It is not it's an empirical rule. So this was identified as TTS board rule of distances of planet. Now, once you found that, okay, Uranus, that is the planet beyond Saturn, now it is identified and it fits. There was a renewed interest in TTS Bode's law. And there was this Hungarian astronomer, Baron Franz Xavier von Zech, who actually gathered a group of 24 astronomers. He went around in nearby places. It was Europe, of course. So he went around various places and then he talked to astronomers and said that, look, let us look for this missing planet between Mars and Jupiter. And they organized this team and they started looking for it. They called themselves Celestial Police and they were looking for it. But there was another person, Giuseppe Piazzi, Italian astronomer. Now there's a question here that how is it that Zach never even invited Piazzi to participate in this particular survey or search, because Piazzi at that time had the best astronomical observatory in the Europe, in the neighborhood, probably in the world. I mean, that was the time we are talking about, 1700s and 1800s. But he was not invited, but he discovered exactly at 2.8 astronomical units, a new object. It was the January 1, 1801. So he discovered this. Initially, people didn't bother too much about it. People thought that it's a new planet. First, he thought it was a comet and so on. Then finally, when you put the orbital elements into it, then you found that, okay, this must be a new planet. But again, the situation that took place is that people were not very happy calling this as a planet. And then eventually it was called asteroid. Now, asteroid is, as an English language, aster is a star. So a star-like object is an asteroid. I think some of you would remember there's a flower, yellow color flower, which is also we call aster, which is even a nice petal star-like thing. So it was found and asteroids were discovered. Now, planet was discovered, but it was not this. It was not such a big planet, so they called it asteroids. Then, in due course of time, few more asteroids were discovered, and by 1850, there were 13 asteroids which were discovered. Then something else that happened in this process, and there was this gentleman. A new technology came into being. That is a photographic technology. Max Wolf was again German. He used photographic plates to look for new asteroids. And as some time back, Sachin has said that there was a method of discovering asteroids. So you take a picture of a sky at one particular direction. Then after some time, you take another picture. Now, if stars would not change their positions, but asteroid would move from one photograph to another, and that is how you can discover a new asteroid. And just in 100 years, the account went from one asteroid to 1901, it is 463 asteroids. And then this number started increasing rapidly. And by 1958, it was 1,600 asteroids. And as you saw that in 1988, when we discovered the first asteroid, Ramanujan, its number was just about 4,130th asteroid. But then another new technology came. And the new technology was CCD technology, the electronic imaging technology. Now, all this thing happened, electronic technology. Now, electronic technology was important because you don't have to take kind of trouble we used to take, when we used to go to the telescope, expose the plate for half an hour, 45 minutes, then collect all these plates, develop those plates next day morning, then dry them, and then send it to Bangalore. So then in Bangalore, I would check them and so on and so forth. With electronic, you just take one image now. After some time, you track one from the other and do it. So this number, just in few years, increased to 5,000. And that 5,000th asteroid was named as IAU, International Astronomical Union, and how it was named. Now, there were two things which I would also like to tell you. And one is, of course, the Tunguska event, where in 1908, there was a big collision, big blast, which was there. But then astronomers also took this thing as a chance event. No one bothered. Frankly speaking, in my era, the astronomers thought asteroids to be vermins in the sky. People didn't like it Because if I am taking a picture of a galaxy and then you find a streak going across, it will completely spoil your, like right these days we have those satellites passing and people are a lot of concentration of iridium. And then they started proposing that it is possibly a new asteroid came, hit the Earth through that dust on the surface of Earth, and there is a marked danger. Then other people like Tom Gerrels and many others who came up, they thought that no, to save the humanity, we must look for new asteroids. So Tom Gerrels actually started the Space Watch Telescope, and there were others who started doing it, and then it became an automated thing. And slowly people realized, in fact, there were two occasions. One is very interesting one in 1972, and many of us would remember that it came into the Sky and Telescope magazine. That is 1972 image. That was a complete, I think, Super 8 film. And the frames were shown where a large asteroid actually skimmed past the surface of Earth. And it was taken from Jackson Lake in Wyoming. Now the threat was really felt. Astronomers started feeling the threat, and then there was a lot of effort by various people saying that, look, we must look for these asteroids, and in case if they are coming towards the Earth, then we should be able to save our at least small locality. Now you would remember there was one particular episode a few years ago where let me see if I have that data, where no, I don't think have that, where the asteroid came and hit the Russian village, and there was a lot of glass scattered everywhere, and people talked. It was very nicely filmed. There was a big sound. So the cutting the story short, the threat is definitely perceived, and there are threats could be in different ways. For example, a 10-meter, okay, it is calculated that if an asteroid is of X dimension, then when it comes and hits the Earth, it would make a dent 10 times more. Okay, so if it's a half a kilometer asteroid, then it will make a circle of 5 kilometers. It's a big number. It's a big energy that is giving it. And worst part of it is that if it hits, like I'm scared that in Bombay, suppose it hits the shore, then we should expect a large tsunami if an asteroid comes and falls. Now, people did started talking about how we can save the Earth and so on and so forth. There was one where, just for the interest of general public, Shantanu, tell me when I should stop. I'll be stopping in 2-3 minutes. So I'm just going on. So it's
Sure.
that you make
2 minutes.
2 minutes, yeah. It's a jungle gym. So what you do is you have a nice 2-inch ball bearings which are connected by threads or spring, okay, and have a nice couple of kilometers jungle gym. And then what you do is you come and if you see the asteroid coming towards you, go and keep it there. So it will vaporize. The idea that we saw in the asteroid, the other movie, where you blast the asteroid, has a big danger. The big danger is that if you blast an asteroid and if it comes, it's one example I can give you that in olden days when we used to go for hunting, then if you aap yadi titar ko marna hai, then you have a charra, you have a cartouche in which it is a large number of charras are packed. So you spread it out. So you may not kill all of them, but large number of them will go. If it's just a ball, it will only hit one particular. But if you want to kill an elephant, then it is just a solid ball. So keeping an blasting asteroid doesn't help. What you need to do is that if the asteroid is going like this, create a blast next to it so that it is diverted slightly. Even if it goes about 50, 60 kilometers above the Earth's atmosphere, you are safe. So that is what people have been talking. And I very much appreciate all of your efforts to get the young scientists, I would call them, young scientists to look for these asteroids, because such numbers would eventually improve the scientific knowledge about how the asteroids are distributed, what are the potentially hazardous asteroids which are there. And then eventually also is the fact that you could even talk about asteroid mining. Just one last thing, that is the space watch telescopes and all that. People have over a period of time, when the electronic thing started,
young audience has a question for you, sir. And the question is, sir, can you please highlight the astronomical significance of asteroids in research sciences?
Well, one is that people thought at one point in time earlier that between Earth and Mars and Jupiter, possibly there was a planet, but which has been now ruled out because there isn't sufficient mass to make one planet. And other thing is that asteroid research. I mean, potential hazardous asteroid is one thing, but even the asteroid research also tells you about what are the prevailing conditions which were there at the time of beginning of our solar system. Because there are many types of asteroid. These asteroids are called main belt asteroid. Then there are Trojan asteroids. There are armor asteroid, which are called the Earth crossing asteroid. There are Mars crossing asteroid. So basically, if you just go look beyond the saving the Earth, then you also talk about the evolution of solar system. So from that angle, again, it's a scientific information. I hope I have
Thank you
answered.
so much. Sir.
Welcome.
Thank you so much, sir. And now we will be moving towards our next guest, who is Mr. Rintunath, senior scientist with Vigyan Prasa, an organization under the Department of Science and Technology. He is the head of the Division of Information Systems of Vigyan Prasar. Mr. Nath completed his PhD from Central University of Rajasthan in the year 2018 and then did a certificate course from Stanford University. He joined Vigyan Prasar in the year 2002, and it's been almost 18 years he is continuously working in popularizing space science. As a professional, he is interested in the field of data acquisition systems and communication techniques. He is actively involved in the development and disseminating innovative open ended science experiments for joyful learning by students. He is also a popular science writer and regularly writes for a number of magazines and journals. There are successful publications published by Sir on various topics such as solar eclipses, public health policies for COVID 19, Indian scientists, and communications. Now, I would like to request Sir to share his views on asteroid mining and future missions. Please, sir.
Thank you, Shantanu, Dr. Parinjbhai, and Mr. Sachin. After your talk, it's a pleasure for me to listen both of you and also interact with Shantanu. I would like to give a small, kind of a talk on asteroid and what are the future missions. I'm not a really expert, but because my profession needs, communication science and different aspects. So I, in fact, wrote a few articles. It is not exactly on asteroid, but what science and technology is there in store. I take a cue from Dr. Parinjbhai, what he said, that the data analysis, a lot of data available, and nowadays the researchers need not do that struggle, that hard work, what earlier used to be maybe 10 years back or so, because of the advent of now high performance computing, distributed computing. Analysis of data becomes very, very easy. So I'll start with saying that asteroids are something, some objects which would like to say, you may love me or you may hate me, but you can't ignore me. Maybe very insignificant, space object. When it comes to hit Earth, then it creates a kind of a phenomena which we rather should not try to physically visualize. It happened, what happened in 1908, is something very devastating, and the same thing if it happens now, with all likelihood, like to overcome, with our development in science and technology, to divert it or maybe to blast it. But definitely, we would not like to see physically that what happens if something of that sort happens, hits the Earth. As Dr. Parinjbhai already said, if it comes to even a small fragment comes to the ocean, then it's going to be a huge tsunami, and if it is on the land, then devastating. So, but that doesn't mean we will not extract, we will not know about asteroid, and what future is there for us to take it. As I said, we can't. We may love it, we may hate it, but we can't ignore it. So it's better that we try to take the best out of it. So there are two aspects I would say today's discussion is. One is a lot of appreciation of astronomy is going to take place in coming years, because the younger generation, they are very interested to know about space, to know about space objects and what how they can contribute. So that's one aspect. So maybe asteroid mining gives an opportunity for the young learners to know what is in store in future, and something like the Hollywood movie, we have all of us have seen several movies which talks about something like shooting once there is a space interspace missions, and then you need rocket fuels, and then you land up somewhere and you get some few materials packed up in there is a recently I saw a movie that I think it's Interstellar, which actually lands in one of the small rocky planets, and that takes up some typical name that they do name those some objects, some minerals, which is not really earthly, but the name very interesting. But that's something is going to be in future. That's our future. Already there are several missions for mining asteroids. There's already two missions are going on, which is from Japan. There's Hayabusa 2, and another from USA. There's Asteroid Rex. These are the two asteroid missions. For USA missions, it's actually going to come in 2023. It's going to come with some asteroid materials. It's called Bennu, the asteroid Bennu, and will come back with that materials. And for Hayabusa 2, it's already mission accomplished. As later part of this year, maybe it will get that sample from the asteroid Ryugu, and it will drop it in a canister. Now, next point is how asteroids can be mined. Now, asteroids are a rich source of many minerals, including some of these costly metals, gold, silver, platinum. This is one aspect of that. But this is something which is not so important, although the value which will create, but whether it will be able to overcome the cost involved so far right now, it's a question now. There are many other issues also. Another thing is, most of these asteroids, they are rich source of water. This is something which to be explored. In fact, there are missions planned now. One is a Planetary Resources Company, which is formed in 2012. Am I audible? I'm just giving a monologue kind of. If Shantanu can confirm. And I see everybody's video freezed. Dr. Paranjpe, I can see what is moving. Can you tell me, am I audible?
Yes, sir. Yes, sir.
Am I audible?
Yes, sir. You're audible.
No, of course you are.
Sometimes I know this connectivity is not so.
No, you are very much audible.
Okay.
I'm listening to you.
So Planetary, one company was formed in 2012. It's Planetary Resources. They actually planned, they would like to make a fuel depot. And from water, from asteroids, they will try to make it liquid oxygen and hydrogen just for refueling purpose of rockets. And also it is planned that it will be, returned back to, Earth, so that the fueling of the rockets possible. This is again a very futuristic plan. There is one more venture that's called Deep Space Industries, which is formed in 2013. In fact, they have already a long-run plan up to 2023 for asteroid mining. They have kind of a plan of satellites named as Fireflies, which will be like a CubeSat satellites, which will be actually simply landing, and it will try to get information, gather information to see whether there's a mineable or not. And they have dragonflies. They have planned dragonflies. There's a small spaceship which will be able to get a small amount of asteroid objects, and thereby they will try to get some of those costly minerals back. And there is harvesters voyage. Harvesters voyage are actually they would like to get a huge chunk of asteroid materials for mining. So this is what Deep Space Industries, they have planned up to 2023. There's one more industry which is coming up, is Kepler Energy and Space Engineering. Similar aspects, similar plan. It's again mostly two parts. One is the fuel out of the ice water form. So extract ice water to get hydrogen and oxygen. and then another is the minerals to get it back. NASA has also constituted a company. There's a NASA Institute of Advanced Concept, the NIAC. They have constituted robotic asteroid, and that's not entirely for asteroid, but a substantial part of their research projects will be towards asteroid belt, and to see what is future, what prospect we have in future from the asteroid belt. So these are the different institutes, different organizations who are in asteroid mining. Now, when it comes to asteroid mining, there are now financial constraints, financial requirements, economical conditions, as well as there are regulations and safety concerns. I'm not going into detail of those, but there are international treaties of whenever is coming for asteroid mining. Things are not yet fully formed, but it is actually under development. So it will be but I'm sure that with ongoing projects, ongoing asteroid hunting mechanism will give us a lot of data to be able to analyze it, so that we see the future how best the resources can be harvested, and we take the asteroids for the best advantage of humankind. And this is going to open up a huge big space research thrust in space research. Yeah.
Excuse me, Rintu sir. Sir, your voice was lost for a minute.
Yeah,
or
I know.
So if you could just repeat the last one or two lines.
At this time, what's happening at around 11, because I'm using the office Wi-Fi, and many my colleagues have started joined in some of these webinar kinds. In fact, I can see my adjacent room. I'm the scientist sitting. He's also joined. I can hear some of his talk now. So it happens after 11. All of us are almost stuck.
Right. And
every time I forget to my LAN, because it's very easy for me to connect to the laptop and the Wi-Fi. So had it been a LAN, anyway, please bear with me. You may keep get disconnected from me, and then again I'll be able to, you'll be able to listen to me. But what I'm trying to tell you again, I just repeat that this is something very futuristic, and that's why it's very important to reach out to students, especially those who are always looking for thrills, And asteroid is actually thrilling, really thrilling, because it's not only information, a lot of information, it also gives you the fear. There's a fear factor. The fear factor, there is huge things, huge scientific discoveries, and also a lot of things to mine, resources. So when we were talking about the long distance space travel, it may be still limited to Hollywood movies, but something which is very futuristic in the discoveries will tell us what is going to be in future. But as I told you, already up to 2023, the planning which many of these institutes have, if it's materialized, is actually we'll be able to see many of these Hollywood movies in reality. So we'll be able to actually have fueling stations, rocket fueling stations, and we'll be able to actually mine many of these materials and the minerals from the asteroid. In fact, the Earth where we are living, the entire crust that minerals mapping and minerals deposit, many of this, it seems to be came from earlier stage, in a formative stage of Earth. The asteroid, has given many of these minerals to the Earth. In fact, the gold, because many of these, iron ore. If you see the ore, iron ores are actually in the core. The original formation of Earth, because it went deep inside the core, and that's how we have, because of the molten iron and nickel form, we have a magnetic field, Earth magnetic field. Now, whatever is mining is happening, many of the minerals are actually on from the crust part or mantle part. This mantle part, in many of the times, it came maybe from the asteroid shower at the Siberia stage, formative stage of this. So that's how also we actually got tremendous benefit from this asteroid in an early stage, in the formative stage of Earth. And that also gives an opportunity to talk about asteroid today. When we talk, the international, we are celebrating International Asteroid Day. So that gives them an opportunity to talk about asteroid. Having a clear picture, of course, but yeah, a lot of learning from that, scientific discoveries, a lot of futuristic missions which has been planned. So let's all celebrate to know more about the asteroids. And I especially invite students to join this a journey, long journey of space mission on this day today on asteroid. Thank you very much. Thank you for your patience.
Thank you so much, Rintunath sir. And I would just like to inform our audience that Dr. Patrick Miller, who's the director of International Asteroid Search Campaign, has also joined us in our panel. And we also have Dr. Gyanluko Masi from the Virtual Telescope Project. And these two esteemed guests would be speaking next on our panel. But before moving on, Mr. Rintunath sir, I have one question for you from one of our audience, sir. Am I audible, sir?
Yeah, you are very much.
Uh, yes, sir. So the question is that if we have to mine an asteroid, it should come close to us. But many of the time that is not possible. Then how can mankind mine an asteroid?
Okay, when we talk about the asteroid mining, it's actually near Earth asteroid. We're talking about near Earth asteroid, and it's actually there are different schemes of going. In fact, as I said, that deep space industries, they have planned three types of journey towards the nearby asteroid. One is Fireflies, is a spacecraft. Basically, there are three types of spacecraft which has been planned. Fireflies, which is small CubeSat type, which will go and land there. And Dragonflies, there's a spacecraft. These are the spacecraft which will be able to take a small amount of payload from the nearby asteroid. And then Harvester's Voyage. That's a very futuristic, 2023 onwards, there it's planned that it will be able to actually carry huge payload from the asteroid. In fact, sometimes maybe a small asteroid itself. And there are three methods of mining that's been planned actually. One is the deep boring, another is extraction from the excavation from the on the top surface, and there is in fact diverting the asteroid nearby Earth Moon orbit, so that the whole of these things can be extracted. So these are all futuristic mission, but we have whatever we know. That's from 2020 to 2023. There are many such missions are going to come up. Two missions are as such is on now, and three more missions are already planned. And NASA is actually funded a substantial part for this development also. Yeah.
Thank you so much, sir, for the lovely talk. I thoroughly enjoyed it. And now, moving on, thank you, Dr. Patrick, sir, and Dr. Gyanluko Masi, sir, for joining us. It's a great pleasure having both of you in our panel today. And the next speaker, I would be moving on to Dr. Patrick Miller. We are happy to introduce to our guests, to our audience, Dr. Patrick Miller, the Director of International Astronomical Search Collaboration. He founded IASC in October 2006 and serves as the Vice President of Permanent Council of Global Hands-on Universe Association. He is also the professor of mathematics and also teaches introductory astronomy and astronomical research methods at Hardin-Simons University, Texas. Space India has been serving as the national coordinator for this prestigious campaign for the last 11 years by giving opportunities to more than 1,000 students every year. So, we'll be talking about the threats associated with asteroids and the Student Scientist Program. Thank you, sir. Dr. Patrick, sir, please. Thank you.
Dr. Miller, are we audible to you?
Sir, I guess, sir, you've muted, sir. Okay. Dr. Miller, sir, I guess you've muted yourself, sir.
Now are you able to hear me?
Yes, sir.
Yes,
Yes, sir.
Excellent. Okay, I guess I had to be smarter than my microphone. Sorry about that. All right, now I'm ready. Okay, let me bring up my presentation. Here we go. Well, as you said, I'm Patrick Miller. I'm in Texas with Hardin Simmons University, and certainly delighted to have an opportunity to speak with your group today, where I want to talk about asteroid threats and how students and other citizen scientists can actually make discoveries and have made discoveries in India for quite a while, since about 2009, 2010. As your previous speaker discussed, these are the things that concern astronomers, the near Earth objects, or NEOs. And here's some photographs showing them. This is the one in the upper left is Phobos. That doesn't pose a threat to Earth. It's an asteroid that's in orbit about Mars. Not very big. It varies around 16 miles or 20 kilometers in size. Then we have others out there by Mars, Eros, which is a Mars-crossing asteroid, along with two other objects, Gaspra and Ida. And of course, these are boulders of rock. These particular boulders are about 3 times the size of Mount Everest. The Eros and Gaspra and Ida, along with its little captured satellite Dactyl, do not currently pose a threat to Earth. However, they are in orbits that will change over time, and the time period over which these orbits change is on the order of about 1 million years. So, in about 10 to the power 6 years, or 1 million years, these objects will actually be crossing Earth's orbit and potentially pose an impact risk with our planet. Looking out into the asteroid belt, we find that the largest and one of the other largest ones, in comparison to the Moon, are the asteroid Vesta and the asteroid Ceres. To give you a sense, Ceres is the largest of the asteroids. It has a diameter of about 900 kilometers. Vesta is one of the larger ones. It has an asteroid. It has a diameter on the order of a couple hundred kilometers, but they're small compared to the Moon. At least that's what they look like today. They probably were originally the size of the Moon, but because of collisions have ground themselves down to smaller objects that we see out in that part of the solar system. NASA sent the space mission, Dawn space mission, out to both Vesta and Ceres, where it spent 1 year monitoring Vesta, and then they flew it across the asteroid belt and spent another year monitoring Ceres. So the photograph I just have put up on the bottom left is an actual photograph from that spacecraft of the Vesta asteroid. And then here's a photograph of Ceres, both as the Dawn spacecraft approached that asteroid, and then as it got closer up, you can see the photograph from the top. And also, as the previous speaker mentioned, these objects are known and have observed to have water underneath their surfaces. And there's some debate about the nature of that water and how it is connected to the water we find on the Earth. looking at the isotopic ratios of oxygen, for example, you can actually determine the reservoir from which the water originated, and it appears that the water that appears in these asteroids may in fact be the same reservoir of water that we have here on the Earth. That's still being debated by astronomers as to the origin of water on the Earth, but most definitely there is some connection there. Looking at the asteroids as a whole, here's a graphic I like to show to students and citizen scientists. It shows you the distribution of this material in the inner solar system. Now, if you take a look, the green here is the orbit of Jupiter, and the red is the orbit of Mars. And then each green dot that you see here in this graphic is the position of an asteroid at the time that this graphic was made. And you can see that most of this material, this rocky debris, as you know, forms a ring around the sun. Now, I say most of it because the blue circle there, or ellipse there, is the Earth's orbit. And if you look carefully, you can see there's also some green dots or debris from the asteroid belt that resides in the interplanetary system, which includes Earth and Mars and Venus and Mercury and the Sun. There's also some material debris out here in Jupiter's orbit that are in Jupiter's orbit. They go around in that orbit. That region, that belt, is called the main asteroid belt, or we just refer to it as the main belt. And the material that wanders in from the main belt from a variety of sources, about 2 to 4 astronomical units. One astronomical unit being the average distance between the Earth and the Sun, or the objects that are in the main asteroid belt have orbits that are 2 to 4 times the size of the Earth's orbit, and they take typically 6 years, on the order of 6 years, to orbit to make one orbital path around the Sun. Now, occasionally this material hits us, and this is the result of an impact that took place here in the United States, in the state of Arizona, about 50,000 years ago. And this is referred to by astronomers as the Barringer impact crater, or just referred to it as the meteor crater. This impact took place, as I say, about 50,000 years ago. And across that crater, it's about 1.5 kilometers. So on the top there, you see an aerial photograph. I think that came from Astronomy Picture of the Day. And to give you a sense of scale, you can see the size of this impact by the people standing on the rim of that crater. There were people living in Arizona, Native American Indians living in Arizona 50,000 years ago, and undoubtedly, when this thing hit, it killed some of those Native American Indians. It's considered to be a religious holy site by the American Indians, and they still return once a year to this crater to honor the passing of their ancestors. More recently, and this of course is what everyone knows about in regards to Asteroid Day, in 1908, there was an asteroid about 60 meters in diameter, weighed on the order of 100,000 metric tons, entered the Earth's atmosphere over Siberia, and burst in the air. It had about a 4 megaton air burst. This was a little more than 100 years ago, above the Tunguska River in Siberia, and of course we call this the Tunguska event. And 20 years after the explosion of that, the air burst of that asteroid, professional astronomers from the Academies of Science in Moscow went to the site. It took them 20 years to get up there, and this is around the middle 1920s, I think. And the third photograph is shown you here is a photograph taken by those astronomers at the location of that impact, or of that airburst. There were some 80 million trees that were laid flat from the epicenter of the explosion. And here's showing you the area of it landed over a forest, airburst over a Siberian forest, and it devastated about 2,100 square kilometers of forested area. In fact, that there's still no trees growing in that area even today. It's just grasslands that have filled in that devastated area. More recently, also over Russia, was this event. This took place in 2013. This is an airburst of an asteroid over the city of Chelyabinsk, and it airburst took place about 30 kilometers above the ground. Fortunately, the airburst took place about 60 kilometers away from the city itself, and so you can see the actual airburst. It took place about 8 o'clock in the morning, and you can see the photograph on the upper left, showing you, it was from a dash cam of a car, showing the airburst almost as bright as the sun. Now, that one had some consequences. It didn't kill anyone, but it did injure a lot of people. This photograph shows you a municipal building in Chelyabinsk. There's actually a video, on a YouTube video, where you can see people walking down that corridor, and as the shockwave from the airburst arrived at the city, it shattered windows, and in this case, it blew the windows into the corridor where people were walking and injured them. And you can see the glass, the shredded glass, all over the floor across that corridor. I think this was a city building, a municipal building in that city. Here's a classroom. This took place in the early morning hours, around 8 o'clock, at which time businesses were opening, schools were starting, people were in their cars on their way to work. And here's a case where the windows were blown in, and you can see students were sitting, and a teacher was sitting in this classroom when the windows literally blew into the classroom and injured the students. Here's some other damage that took place in this city. That there's a construction area where a brick wall collapsed from the shock wave. And you can see probably an industrial building where the windows have been caved in. And I think this is an apartment complex in the very bottom where the windows were also caved in from the air blast. There were some 1,500 people had to seek medical treatment. And in the area of Chelyabinsk, and I think there were five small villages. There were 7,200 buildings that were damaged by this event. So these are very real threats. The one that took place 50,000 years ago that killed Native American Indians. The one that took place in Tunguska in 1908, around which we celebrate Asteroid Day, we don't think killed anyone, but it certainly killed indigenous wildlife that were in that forested area. But it could have, if it had arrived it arrived also in the early morning hours, around 7 o'clock in the morning. Had it arrived at noon, the airburst would have taken place over St. Petersburg. And in 1908, there were 1 million people living in St. Petersburg. And had that happened, a 4 megaton release of energy would certainly have killed many of those people. It was just very fortunate that the one that airburst in Tunguska and the one that airburst near Chelyabinsk were far enough away from any populated areas that nobody was injured. But it's just a matter of time before one of these things will come in and airburst over a major metropolitan area, and people will be killed. So let's talk about a program in which India has been participating in for a long while now, and how it's possible that India may save the world. This is the program ISAC, or IASC. This stands for the International Astronomical Search Collaboration, and it was founded in October 2006 at Hardin-Simmons University here in Texas. What it is an online educational outreach program in astronomy, and it's for high school students, college students, amateur astronomy groups, and citizen scientists. What we do is we provide images that we take recently at professional observatories. We provide these online, and the students, amateurs, and citizen scientists then download these images. They search through the images. They find and measure asteroids, and they do make original discoveries of asteroids. Then when these discoveries are made, Isaac gathers the information and then prepares reports from the student reports and sends those to the Minor Planet Center at Harvard. The Minor Planet Center is the world's official repository or organization responsible for maintaining records on asteroids and other small bodies within the solar system. When we started in October 2006, we had 5 schools. These were schools that were based in the United States. And since then, since October 2006, Isaac has grown to more than 2,200 schools that participate each year, and teams. We also have teams of amateur astronomers and teams of avid citizen scientists who want to study asteroids and make discoveries. We have 2,200 that participate each year, and they're now located in 80 countries. Since that time, students have discovered more than 1,700 asteroids from the main belt, including 2 that outside the main belt that were Earth-threatening near-Earth objects, NEOs. They've also discovered 1 comet and a variety of asteroids that are outside the main belt, such as the Trojans that are in Jupiter's orbit. 62, now this is to date, this is the number that changes over time, but to date, 62 of these asteroids discovered by students and citizen scientists and teams of these groups have been cataloged and numbered by the International Astronomical Union in Paris. And when an asteroid does become numbered and cataloged, then the students who made the discovery then can propose a name to the International Astronomical Union. And these 62 asteroids have been named by their discoverers. One of the telescopes that we use is this one. This is the Pan-STARRS, located in Hawaii. It's located on Maui on the mountain of Haleakala. Haleakala is the 2nd largest mountain in the state of Hawaii. The Pan-STARRS stands for Panoramic Survey Telescope and Rapid Response System, and is managed by the Institute for Astronomy at the University of Hawaii. Main campus is in Honolulu. In the upper left is a photograph of that telescope. There are actually 2 telescopes. There's a Pan-STARRS 1 telescope, and right next to it is a Pan-STARRS 2 telescope, and we use images from both telescopes. It's not the world's largest telescope. It's 1.8 meters in diameter, but what it currently has is attached to it is the world's largest digital scientific camera, or what we call CCD. And this camera produces images that are very large, astronomically speaking, from an astronomer's point of view. They stretch 3 degrees across the sky, and they fill an area about 6 times the size of the full moon. One of the images that we have from that telescope contains about 1.4 billion pixels. So what we'll do is we'll get anywhere from 20 to 30 this month. I think we got 43 of these images in order to support the program in India that's running this summer. We then partition each of those images, those huge images, into about 200 sub-images, and we distribute those out then to the participating schools. And then the students look through those images and can make as many as 150 main belt asteroid discoveries. Another telescope we use is this one from the Catalina Sky Survey. This is at the Lunar and Planetary Laboratory at the University of Arizona. We also obtain images from that telescope. The program works easily. Here's how it works. We get images from the Hawaii or Arizona. We process those images and we put them out onto the internet into our website at Hardin-Simmons University. Then the students and citizen scientists come in and use a program called Astrometrica to look for, to search for, discover, and measure asteroids. They send the measurements to us and if to Isaac, and if there's a discovery, then we will use another network of telescopes to look for a second observation of the asteroid, a confirmation, and repeat the process. And then report those observations, the one that the students made originally, plus any observations that Isaac makes, report those to the Minor Planet Center as an official discovery or potential discovery. There are some students who participated. This is a high school student from Massachusetts. She's made a discovery a number of years ago. These are college students in Texas, near Dallas. These are students in Brazil, near Puerto Alegre. They made discoveries over the years. These are students in Bulgaria who are looking for and discovering asteroids at the National Observatory. This is the National Observatory China in Beijing, and these are Beijing high school students with their instructor there, Hongfeng Gao, using Astrometrica to search for asteroids. This is Portugal. We have each year about 75 schools that participate from Portugal, in former Portuguese colony. This is Japan, Shizuoka University. Students in Isaac looking for asteroids. United States, these are high school students outside of Washington, D.C. These are 3 students in Mozambique using Astrometrica to search for asteroids. And of course, India. We have more schools from India than we do any other country. We have 500 schools that participate from the New Delhi area through the organization SPACE, and another couple of hundred teams each year throughout the country that participate. Poland, students receiving some awards for asteroid discoveries that they made in Isaac. This is Brazil. We have 200 or 300 schools that participate each year from Brazil. Sao Tome and Principe. This is Morocco. These are students from Morocco who are participating, holding their certificates. These are 2 students who received special recognition, Christian Martins and Bruna Pontes from Brazil. And let me close by saying that Isaac is funded by NASA. We have a grant through the Planetary Defense Coordination Office, and our job in Isaac is to use citizen scientists around the world, or have citizen scientists around the world, make original discoveries. In particular, look for near-Earth objects that threaten to impact our planet. So that is our program, and we're very pleased to have Space and other teams from India actively participate, and have been doing so now for many years. And we hope you participate for many more years to come.
Thank you so much, sir, for this lovely speech on the dangers of asteroids and the history of International Astronomical Search Campaign. Sir, I have one question for you from one of our audience. And the question is, sir, the student wants to know that what are the parameters for deciding whether an asteroid is potentially hazardous asteroid or not?
I have to go back and think about that for a second. It has to have a certain minimum distance that it approaches the Earth. I forgot exactly what that is. I have to go look that up. But there are some requirements in order for it to be potentially hazardous. And there's a certain minimum distance of approach to the Earth and a certain size, too. I think it has to be about 140 meters larger in size. And then basically that size is big enough if it were to airburst or hit a city, would probably destroy a city. And there's a minimum distance also requirement. I've forgotten what that is.
Thank you so much, sir. Thank you so much for answering the question. Yes, sir.
Shantanu, I have a question for Patrick Miller, sir. Hi, Dr. Patrick. This is Sachin Mama. I am the chairman of Space India, and it has been a wonderful association with IASC, and it's a dream project. When I was a student, I always thought if I could get a possibility of working on searching for an asteroid, and the possibility that you bring to Indian student is really wonderful. And you have seen that it has been a wonderful association with you, with more than 2,000 not discoveries, but identifications of asteroids done by Indian students, and there were more than 100 discoveries done by Indian students in All India Asteroid Search Campaign. There is one question we have been asking time and again, and most of the students bother me with that, is the asteroids which were discovered in 2010, there should be now possibility of naming them for these students. And they've been asking this question to me time and again. I just wanted to know, when is it possible for the asteroids that were discovered by Indian students, when can they name them?
Okay, you're right. I think we do have one or two asteroids so far that have been numbered by the IAU that do come from India. It's not a guarantee that if you discover an asteroid in 2010, that by 2016 or 2020 there will be a sufficient number of observations for that asteroid to be named. It has to be observed at three oppositions. In effect, you have to have the orbit known well enough to within required statistical standards before the IAU will actually number it. And sometimes that can be done in 3 to 4 years. Sometimes that takes longer, 10 years or so. You can expect that of the asteroids that go into a preliminary status, that about 10% of those will be provisional, will be confirmed. And of those 10%, you can expect 10% of those to receive number status. So even though we've discovered 1,700 asteroids, you'll notice that only 62 of those to date have been numbered. It's a long, tedious process. But what we do is we monitor every single month. We monitor the provisional status and the numbered status of the asteroids, and so we know immediately if you have any that are numbered. And as soon as we find that out, we notify the organization like Space immediately, or the teacher, or whomever we have contact with over the years. So tell them be patient. They just have to be patient. I wish I could tell you, and it's even more complicated than that, because once you make a discovery, we're only allowed to send in 2 names every 60 days from an observatory. And so we have a backlog of asteroids that have been discovered by students that we've had to wait months and months to be able to submit, because it takes so long for this to happen.
Thank you, Dr. Miller. Thanks a lot.
Thank you, Dr. Miller, sir. Now,
Shantanu, I just have one more request for Dr. Miller. Dr. Miller, students in India, we invited you to come to India, and it was ironical that because of COVID, you also accepted that it was a possibility for you to travel to India. So we are all looking forward to your travel to India as soon as you can, because there are more than 100,000 students who are waiting to meet you, and I don't know we'll be able to accommodate here or not. But I'm sure once you travel to India, you'll be one of the celebrities. Just a lighter question. One more lighter question. Today on Asteroid Day, we don't have an asteroid which has a near approach to Earth. So any comments on this from the panel? Just a lighter question.
Well, we did in 1908.
Yes. Okay,
I
thank
do
you,
want to
Shantanu.
mention. I do want to mention that I have great respect for Dr. Devgan, Chandra Devgan.
Yes.
He and I started. Actually, I forgot exactly how this happened. Whether I approached him or he approached me, I think he probably approached me in
Yes, in fact,
2010.
yeah. I'll give you the background on this. One of my friends, he used to study with me. He went to US and discovered an asteroid. So, I was after Dr. Devgan, Mr. Devgan, that we need to start this program in India, and he somehow opportunity came to Indian students, and in fact, in the years to come, we are thinking of participating not only in All India Asteroid Search Campaign, but also to take up IASC with few students who would like to come at our camps called Astroports. So in India, we have now around 16 observatories where students come and enjoy astronomy and space scientific research. So we call them in small groups. So we'll be sending a request to you soon for participating in few IASC campaigns also as an independent team. So yeah. Thank you, Dr. Miller. And now we are all heading towards the next speaker. We all, again, a good association with him on Virtual Telescope, and he has always been very supportive to our activities of Space India in India. So welcome, Mr. Gyan Lukamasi, and we look forward to hearing from you.
Thank
Good
you,
morning.
Sir.
Let
Yes,
you
sir.
introduce.
So I'll just introduce you, sir, to our guests.
Thank you very much.
So our next speaker would be Dr. Gyan Lukamasi. So observed the sky from Cesano, 90 kilometers south of Rome. He graduated in physics from the University of Rome with the highest grades and earned his PhD in astronomy from the same university. He became interested in astronomy in the late 70s, according to his own biography, owing to the sci-fi shows and series like Star Trek and Space 1999. He is the national coordinator for Asteroid Day in Italy, and it is my great pleasure in having both the national coordinators for Asteroid Day for both the countries, India and Italy, with me here today. In 1989, he was the first in Italy to notice the disappearance of one of Jupiter's equatorial bands. He started his journey from focusing to the cosmological distance ladder, then Hubble's constant, to minor bodies of the solar system, to searching of near Earth objects and exoplanets. In 1997, he discovered his first variable star near the Dumbbell Nebula. His list of discoveries doesn't end there. Throughout the years, he has discovered 14 asteroids, co-discovered 14 asteroids, co-discovered 3 exoplanets, and has discovered some more variable stars too. He also co-discovered the most luminous supernova observed in the recorded human history. Since 2006, Sir is the curator of Planetarium of Rome and heads the Virtual Telescope Project. He is also the national coordinator for Italy in Astronomers Without Borders and is the ambassador for dark skies by International Astronomical Union. The asteroid 21795 Masi is named after Sir to acknowledge his contributions to the field. I welcome Sir over here to speak about the importance of Asteroid Day with us and enlighten all of us. Thank you, Sir. Please.
First of all, friends, I want to thank you for your invitation and for organizing this wonderful meeting. It is a pleasure for me to be here and to listen to you and to learn together about asteroids in this very special day. We are celebrating all together these fantastic astronomical objects. And it's a pleasure also to be here together with the National Coordinator for India. It's fantastic that we can really work together under this common idea and bringing asteroids to the community. And I must say that these last years, well, I must say, I would say the last decades, because I started my interest in astronomy when I was a child, like many of you, I was really attracted by the idea to bring to the people the wonders of the night sky, just to share what was keeping me awakened in the middle of the night. And my friends at that time told I should be crazy to stay outside at winter, in the cold night to look up. But I knew that it was well rewarding looking at the stars and so on. And I decided to be a professional astronomer, but in my heart, I feel an amateur. I mean, I always have the same passion, the same love as so many people around, like you, my friends. And it is for me really a joy to share all this. And Asteroid Day is part of this mission, and Asteroid Day has been around now for a number of years, and I must say it was and it is. Time showed it is a wonderful idea, and we are very grateful to the 4 people who founded Asteroid Day, and one of them is no less than Brian May, a rock star, but a great astrophysicist as well. And I like to mention this because it just means that science, art, and other things are always communicating, and there is a continuous contamination between among these different things. Anyway, personally, I joined Asteroid Day since the very beginning. The first edition was in 2015, so now we are celebrating the 6th edition of this celebration. And of course, at the beginning, it was smaller than today. The Asteroid Day really had an impressive growing over the years, and now there are many national coordinators all around the globe, and I can say with pleasure that the idea of a national coordinator was mine. In 2016, I suggested to my friends of the Asteroid Day, of the International Board, to consider the idea to have such a national figure to handle and organize at its best the events locally, because our planet is small, but from an astronomical point of view, but it is huge from a human scale. So having people like in India, like in Italy, just taking care locally of this important event could be better. And history say that it was a nice idea. So I'm happy that I had that idea and that it was actually understood and appreciated and used in the future. And I want to say also another thing, just telling a bit more about myself and why I am so engaged in Asteroid Day. You mentioned the Virtual Telescope project, which is something very important in my scientific and professional and personal life. I live in Rome, and Rome, as every big city, is not the best place to look at the stars. I am lucky if I can see the moon, a handful of bright planets, and so on. Unfortunately, we are really missing the night sky, and this is terrible, to say the least. This is why I decided to build my observatory in the little town where I grew up, which is about 100 kilometers from Rome. Good idea, yes, but the problem was that to use those telescopes, I had to go back and forth every night, and it was not easy because driving early in the morning at winter when you are tired, well, it was not easy. And many times I preferred to stay in Rome without observing instead of going there and working hard and late in the night. So I started thinking if I could make my observatory available remotely. All this happened 15 years ago, and 15 years ago, it was not easy to make a remote observatory. In these 15 years, technology improved in an incredible way. So 15 years ago, I'm not saying last century, I'm saying 15 years ago only. But from a technological point of view, things changed a lot. And at the time, I had to work a lot to make this system available remotely. I succeeded, and I could do my personal scientific work from this very desktop in Rome with the observatory far away. But as soon as I did this, another idea was in my mind. Now that my telescopes are basically connected to the internet, it was very easy to make the images the telescopes were taking available to the public immediately. This was quite easy, so I started this public side of the Virtual Telescope project, organizing live meetings. At the time, we didn't have Facebook Live, we didn't have YouTube Live, and the meeting were textual. There was a chat running with just screenshots and me explaining and writing as crazy because I could not speak. There were no this live streaming, just text. It was crazy, I must admit, but it worked. And now the Virtual Telescope is really a leading facility, sharing astronomy live with the world. And asteroids are the principal topic of our events. I cannot count how many near-Earth asteroids approaching our planet we shared, and also very, very extreme close approaches were tracked and documented by the Virtual Telescope project. I say this just to make clear that when the Asteroid Day idea arrived, it was love at first sight for me, because those people introducing Asteroid Day to do my little part and as you know, now there are many events locally, even if this year is a truly strange one. You know, here in Italy, we are still facing hopefully the end. We had terrible months in the past, and Italy has been really suffering a lot by this issue, you know. And of course, this also affected the capability to organize physical events this year everywhere. But still, no matter this, we Asteroid Day worked to have something to offer. And I also remember that last March, at the end of March, there was another initiative involving the Asteroid Day team as well, and it was Space Connect Us, when we asked to astronauts to bring their experience to us, to share their suggestions to face lockdown. You know, when you are out in the space, in the outer space, you're basically living under lockdown conditions. You cannot go easily away from there. Just to tell you how Asteroid Day is able to improve also the quality of your life with suggestions, with hints, inputs from scientists, from astronauts, from celebrities. And what I really love in Asteroid Day is that different people are together. I mean, not only scientists, not only astronauts, but also writers, but also artists, but also celebrities, just because we are, after all, the same people facing the same problem. If an asteroid will going to hit our planet, it will be a problem for whole the community, you know. And for me, having Asteroid Day, just promoting, the discussion, the knowledge of asteroids is extremely, extremely important. I could stay here talking for hours about the importance, at least how important I see Asteroid Day to be. And I also want to mention that Asteroid Day is now an official event recognized by United Nations. And I remember when a few years ago that happened, and it was an incredible emotion. And again, I am truly indebted with the founders of Asteroid Day for introducing this and sharing this beautiful idea with the world. And as you know, Asteroid Day really, together with local national events coordinated locally by an Asteroid Day reference, from Luxembourg here in Europe, we had Asteroid 6-hour-long live, just bringing and so on. I had the pleasure to be there every year, both as a guest and as a host. And this year, the international the board decided, of course, we could not go there because it is not so easy to travel in safety. But the international board decided again to keep Asteroid Day live in this digital form, with everyone connecting from home and contributing the same. And for me, seeing all these people like you, like me, and many others, just cooperating to share with the world what we know about asteroids, because asteroids can hit our planet, and we really don't like this, and dinosaurs would have a similar idea, very likely. But asteroids can be also a resource, as we have been hearing from the other guests here. So it is important to keep in. There is already a very important good side, because studying asteroids, we learn about our past. And as Italy, as India, we have such a very ancient history behind us. The solar system has the same. And by studying asteroids, we can really learn why we are here. So please don't think of asteroids like a problem. They can be a problem. And I used to say this, my friends. When an asteroid approaches us and likely brings with it the idea, the fear of a collision, it is not just doing this to fear us. It is just remembering us that there was an ancient mechanism, that is collisions, which made possible two planets to form. After all, this is an echo of a very positive phenomenon, which is now why we are here. So we have to learn why things are happening. And science is here to help, just understanding, just putting some light somewhere to help us understand what is going on in this beautiful place we share and we call the universe. And for me, Asteroid Day has been, and it is, a truly fantastic, a winning idea, because it is doing a super work. And I think that we cannot go back. We cannot stop Asteroid Day after we enjoyed its nature, because now we need it. And I'm looking forward to many new editions to come, to organize together with you and the other friends of Asteroid Day, really.
Telescope project, and I guess I'm correct that when I say thank you, sir, for making the project, available for people around the world by being in Italy, and that's a very big contribution. So thank you so much, sir. Yes, sir.
I thank you for the invitation, but I also want to thank Space India, because we worked together in several occasions in the past, and also very recently, because, 10 days ago, basically, there was a solar eclipse involving your region, and the virtual telescope was able to show the eclipse to the world, also thanks to the contribution from India, from people from Space India. So it is me saying thank you to you, friends, because sharing what we see up there with the world is just fantastic. And I feel this like a mission. I cannot live without sharing what I love. When you love something, your natural inclination is to go out there and tell to the people why you are loving that so much. And I'm happy to be in such a very good people like you, doing the very same thing. So thank you.
Thank you so
well.
much, sir. It's been a pleasure collaborating with you. And sir, before I just move on, I have, by just looking at asteroids, how do we know? Like, we have not seen the whole orbit. We don't see them completing the orbit every day. So how do we know that the asteroid might collide with us in, thousands of years in the future, or hundreds of years in the future?
Well, when you find an asteroid, by the way, I really appreciated that Dr. Miller presentation, because it made crystal clear many concepts. When you find an asteroid, the very first time you see it, in principle, you don't know what is its orbit, okay? So it is important to keep an eye on these new discoveries, especially those objects which are clearly on orbits, bringing them in the inner solar system. When you find, of course, we are lucky that the near-Earth objects are a small fraction, okay, when you compare them to the entire asteroid population, because the asteroids are really a lot, hundreds of thousands known to date and many more to found, but there are just a few percent of that number are near-Earth asteroids. But the problem here is this: when you find an asteroid on an orbit, bringing it in the inner solar system, you have to monitor it closely to understand the real orbit of that object, to better evaluate and address the impact probabilities. And sometimes, when you measure something, there is always an error connected with the measure. So you can say this asteroid is going to hit us or not with this probability. And in order to hopefully see the impact probability going to zero, you have to monitor it long enough so that the quality of your measurements will have the error going down. And there are some techniques like numeric integrations to also understand what an asteroid will do in the near future. And this is why the potentially hazardous asteroid category exists. And this category, this name, potentially hazardous asteroids, is just labeling asteroids larger than 140 meters and coming closer than 7.5 millions of kilometers. And that could be of interest from an impact point of view, and we have to monitor them to see what they will do at some point in the future, because we cannot calculate everything now. Just accumulating observations, we can hopefully propagate in the future, in the far future, what we know today. But to date, we are safe. But you never know what our telescopes will discover tonight.
Thank you so much, sir. Thank you so much for the
My very pleasure, my friends. We have a nice asteroid, everyone.
Same to you, sir. Thank you so much, sir. So with this, we come towards the end of our panel discussion by our experts. We had amazing topics today. We got to learn about the importance of Asteroid Day. We learned about the prospects of asteroid mining, about the dangers of asteroids, but we also learned that asteroids could be our best friends. So now, just before ending our today's enriching panel discussion, I want to come to three other people who have joined us and who are actually provisional discoverers who are associated with us in Space India. So with me, I have Nikhil Jha, I have Ravi, and I have Jagrit with me, who are provisional discoverers of asteroids from India. So before I move on to others, I would start with you, Ravi. Hello. Thank you for joining us in the panel today.
Hello, sir. Thank you.
It's been
Last year, sir, I was going through internet, and then I came through the AIASC campaign. I just wonder what is it, because, sir, I was always fascinated about space and stuff. I used to read books by Stephen Hawking and the history of astronomy, sir. So when I came through this campaign, I was quite fascinated. I will get opportunity to interact with this thing, that how the things actually go in real world. So I registered with my partner. And then we started to get the data set, and when we were provided with the software, I was feeling like I am on the top of the world, because it was like the raw data from the telescope, and I was analyzing it, and then I suddenly found a moving object. I was like happy, yo, and then I made a report of it and sent. And after some times, actually I also find some more objects, but I think that I was not the first to find them. But the first object I discovered was was a categorized preliminary discovery. Then a few weeks back, I received a mail again that it has been provisional discovery. So I was quite happy about that. I called my partner, bro, we did it. So I would like to thank AISC and IASC for providing me this opportunity, so that I got at least once my dream fulfilled of being, feeling like a scientist.
That's amazing, Ravi. Indeed, it's a chance of a lifetime discovering an asteroid.
Yes, sir.
And I'm glad you could associate with us.
Yes.
And now moving on, I would come to Jagrit. Hi, Jagrit. How are you?
Hello everyone, I'm Jagrit Goyal. Today we are remembering the Earth's largest asteroid impact on 30 June 1908 over Siberia, Russia. I was a part of a team that discovered an asteroid in 2018 through All India Asteroid Search Campaign conducted by Space India and International Asteroid Search Collaboration. Friends, Space India and IASC are working together in promoting and popularizing space science among citizens. They are also providing real-time research experience to astronomy enthusiasts like me. They offer possibility of making our own discoveries and naming our discovered asteroids, which is really huge. I feel highly privileged to be associated with their campaigns. The kind of training and guidance they provide is inspiring and invaluable. We were trained on usage of Astrometrica software for analysis of the high quality datasets and images provided by IASC through the PANSAS telescope. I wish everyone a very happy Asteroid Day and happy hunting.
Thank you so much, Jagrat. Happy Asteroid Day to you. And in the end, before concluding our today's panel discussion, I would like to move on to Nikhil. Hello, Nikhil. How are you?
Hi, I'm good. So I would first of all like to thank Space India and ISC to conducting such kind of programs in India. And these kind of opportunities should be there for children like us who are so curious about to know more about space. And I would just expect from Space India that they will conduct more such kind of programs and give more opportunities to children. And happy Asteroid Day to all and happy hunting. Thanks. Thank you to all.
Thank you so much, Nikhil. We'll make sure that students like you, curious students like you, always have opportunities to contribute to science. With this, everyone listening to this discussion over here, we have reached the end. Thank you so much to all our esteemed guests, Mr. Arvind Paranjpai, Mr. Rintunath, Dr. J.P. Miller, and Dr. Gyanluko Masi. And also thank you to Mr. Sachin, sir. And thank you to all our asteroid discoverers for joining us and making this a very lovely and educational session. I, for once, had a lovely morning today. So thank you, everyone.
In fact,
for joining us.
Yeah, Shantanu, all of us want to thank you for wonderful coordination that you did for this session. Nice work. Nicely done. Thank you, everyone. Thanks a lot.
Thank you, sir.
In this Asteroid Day exclusive, we introduce you to people who are leading the efforts to investigate asteroids in our solar system, including their potential for great destruction of all we find precious on Earth. The series will take us from what we know today to new discoveries in science and technology that can safeguard generations to come. Asteroids are leftover matter from the formation of planets. Most of them orbit in a belt between Jupiter and Mars, the asteroid belt. But some of them have entered the inner solar system and crossed Earth's orbit. Those are the ones that need attention. Asteroids tend to be dark and move against a black sky. If a large one collides with Earth, the destruction would be greater than anything we've ever seen.
A meteoroid or fragments of space junk. From collisions among
June 30th is Asteroid Day, and we hold it on the anniversary of the largest asteroid impact yet witnessed. Part of the Siberian forest, spanning an area nearly 1,000 square miles, was flattened